Hey, hello there, welcome to CS School channel. In this video we are going to solve merge overlapping intervals problem. This is a pretty interesting problem. I have added link to this problem in the description of this video, so do check it out and try it on your own. If you can't solve it, come back to this video. Now let's discuss the problem statement, which is also given on the screen. So you are given an array of intervals. An interval is nothing but array of two elements, start and end. You need to merge all the overlapping intervals and you need to return the array which contains all the non-overlapping intervals. So when do we call two intervals as an overlapping intervals? We will call two intervals as overlapping intervals if the end of the current interval is greater than equal to start of the another interval. Okay, so take example of 1, 5 and 4, 8. As 5 is greater than 4, right? So this we call as overlapping intervals. And take another example where we have this interval as 1, 3 and the second interval is 4, 8. As 3 is not greater than equal to 4, these are non-overlapping intervals. So hope you got idea about overlapping and non-overlapping intervals. So these are some of the sample inputs and outputs given in this problem. In the first sample input, we are given an array with first interval as 1, 3, the second interval as 2, 6, so on and so forth. Okay, and the output is the first interval as 1, 6, which is kind of the merge interval of 1, 3 and 2, 6, because the first interval ends at 3, the second interval starts at 2, so these are kind of overlapping intervals, so we have merged them, right? And we have copied down the remaining intervals because they are not overlapping. Similarly, look at this example. We are given an input with the first interval as 1, 4 and the second interval as 4, 5, and we are merging this 1, 4 and 4, 5 and just creating the single output interval. In the third example, we are given this large array, and after merging all the overlapping intervals, we get this final output array. Okay, so how did we merge? We merge 1, 3 with 2, 6, okay, and 2, 4. So see, 1, 3, this 2, 6 and 2, 4, and we get the final merge interval as 1, 6. Similarly, we merge this 8, 10, 8, 9 and 9, 11, and we get the final merge interval as 8, 11. Similarly, we merge this 15, 18 and 16, 17, and we get the final merge interval as 15, 18. So these are the three intervals which are kind of final output in this problem. So if we look at these three problems, we will observe that first two problems are pretty easy to solve, but the third problem is hard. The reason why it is hard, because the intervals are not properly sorted in this problem. Okay, so see, in the first problem, 2 comes after 1, then 8 comes after 2, then 15 comes after 8. In the second problem, the 4 comes after 1, right? But in this third problem, see, at the end 2 comes after 15, right? So this is not properly sorted. So what we can deduce from this is that this problem becomes really easy if we sort the intervals, right? Now let's see what happens after sorting this entire array. So after sorting, this is the intervals array that we get. So if you see, this 2, 4 has moved from the second last position to the second position. Now after sorting, we can be sure that all the intervals which can be merged are adjacent to each other, right? So what we can do, we can just iterate over this array one by one and see if the next interval can be merged with the current interval. Okay, so what we will do, we will start with this 1, 3. We will see if 2, 4 can be merged with this 1, 3. Can it be? Yes, because 3 is greater than or equal to 2, right? So we will merge these two intervals. Now our interval becomes 1, 4, right? And we just repeat this loop until we reach to the end of this array and we get the final merged array. So hope you got the intuition. Now let's look at the algorithm. This is the algorithm to solve this problem. So the first step in solving this problem is to sort the intervals array. Then we will create a temporary variable called as temp interval, which will store the current interval which we are processing. Okay, initially the value of temp interval will be the first interval. Then we will iterate over all the remaining intervals. Then we will check if the current interval on which we are iterating, can it be merged with the temp interval. If it can be merged, then we will merge it. If it cannot be merged, that means the temp interval is the final interval in the resultant array. Okay, so we will push it into the resultant array and we will return that resultant array at the end of this algorithm. So now let's see the step-by-step execution of this algorithm. So now let's go over the algorithm step by step. So we got this input array. After sorting it, we get this array as an output. So initially we will consider temp interval, which will be the first interval in the input array. And we will also create another variable called as final intervals, which we will use as a resultant array. Now we will consider 2, 4. So is 2, 4 overlapping with the temp interval? The answer is yes, because 3 is greater than equal to 2, right? So we update the temp interval with 1 and 4. Then we consider 2, 6, which is the next interval. Is this interval overlapping with the temp interval? The answer is yes, right? So 4 is greater than equal to 2, right? Then we update the temp interval again. Similarly, we go over 8, 9. Is it overlapping with temp interval? The answer is no, right? So we update the final interval with the temp interval, and we will consider the temp interval as 8 and 9. Now we'll go over 8, 10. We will see, is it overlapping with the temp interval? The answer is yes, right? So we update the temp interval with 8, 10. Okay. Then we go over 9, 11. Is it overlapping with the temp interval? The answer is yes. So we update the temp interval. Now we consider 15, 18. Is it overlapping with the temp interval? The answer is no, right? Then we update the final intervals with 1, 6 and 8, 11, and we update the temp interval with the new interval. Okay, 15, 18, right? Then we consider 16, 17. Again, is it overlapping? The answer is yes, right? So we update the temp interval with 15 and 18. Now as the input array is over, we push the final temp interval into the final intervals, and the final intervals become 1, 6, 8, 11 and 15, 18. And then we will return the final intervals as an output of this function. So now let's look at C++ solution for this problem. In this solution, we need to complete this merge function, which takes intervals as an input array. So the first step that we have done is that we have defined this final intervals array, which we need to return at the end of this function. The first check that we have done is we have checked whether the intervals array has 0 size. If it has 0 size, that means final intervals is an output for us. If it doesn't have a 0 size, that means that we need to first sort the array. After that, we have just sorted the array, and then we have taken in temp intervals, and then we have initialized temp intervals with the first interval. After that, we have iterated over all the intervals, and we have checked whether the next interval is overlapping with the current interval, the temp interval. After that, we have run the for loop on all the other intervals, and in each of this iteration, we have checked whether the temp interval is overlapping with the current interval. If it is overlapping, we have kind of initialized the temp interval end with a maximum of the current intervals end and the temp intervals end, as we have seen in the algorithm. If it is not overlapping, then we have pushed the temp interval into the final intervals, and we have initialized temp interval with the new interval. And at the end, whatever the temp interval is, we have pushed that temp interval into the final intervals, and at the end of the function we have written the final intervals. So hope you got the solution for this problem. Now let me just run this code. For that, I have written this main function which creates a 2D vector intervals, and it passes that intervals to the merge function. It stores the response which is coming from merge function into the resultant variable, and at the end I have written a for loop to print out the response. So let me just run this code. So I will first compile and then run this code. So see, in the output, we are getting the merged overlapping intervals. So what's the time and space complexity for this problem? The first step which we are doing is kind of sorting the input array. So sorting has time complexity of O of n log n. Okay. And the second step which we are doing is we are iterating over the array to kind of merge the overlapping interval. So that has time complexity of O of n, right? So in asymptotic notation, time complexity becomes O of n log n, as n log n is greater than n. And what's the space complexity? As we are using an extra array to store the overlapping intervals, we are using O of n space. So hope you got an idea about how to solve this problem in the interviews. We will be making more such videos in the future, so do remember to subscribe to our channel. If you have any questions, do ask me in the comment section. I will be more than happy to help you. Hope to see you in future videos.